right, today, folks, we're going to talk about angle vocabulary initially, and then angle addition.
Yay! Oh wait, frame here.
Thank you for being excited, Ms. Barnett.
I am. I like angles.
All right, well, this happens to be one angle. There are specifically two rays that share a common initial point. I wonder, Ms. Barnett, if you remember what a ray is.
Oh, take me.
Do tell.
It's a vertex.
Okay, the initial point is called the vertex. Fancy word, isn't it?
It is. I think it's a neat word. I think that's why I like angles, actually.
Draw an angle and name it PTR. I think you should draw the angle and name it PTR.
I can do that. So an angle is two rays. So I'm going to draw one ray here, and they share an endpoint, and I'm going to draw another ray there. And its name is PTR. I'm going to go in order.
So does it matter what order you put it in, Ms. Barnett?
Yes, very. Well, yes, I can't say PRT, or I can't start with the P here. I have to put the P there.
So she went P to T to R. So T is in the middle, T has to be at the point. It has to be at the vertex. This is the vertex right here. All right, going on naming the angles. The angle can be named in 4 different ways.
Okay, can I do this?
Yes, you can do it.
Yay, okay. So if I name I can name it in order. So if I go in order, I can go C, H, S, or I can say S, H, C. Or, because the vertex is so important, I can call it just angle H. And every once in a while, if I have a number 1, don't confuse it for something with a degree next to it, but I can say angle 1.
So all of those things should fit in this little bitty space. Looks like we didn't leave enough room. Oh well.
Should I redo that?
No.
Okay.
The vertex. Where is the vertex? Is it C? Is it S? Is it 1? Is it H? Where is the point of this? What is the point of this?
It is the most important point, so it is in the center.
Here it is.
Yep.
This is the vertex. So in our case, the vertex is H, just H. So all points are capital letters. We knew that from last couple times ago.
Yep. Lesson 1.
Now we're going to name the 2 rays. The rays have an end point and they go into one direction. So here's one ray. HS, right?
Why don't we say SH, Miss Cintron?
Because we always go in the direction of the arrow, from the end point in the direction of the arrow.
Just like when we read a book or when we're reading a sentence.
H to S. But there's something missing here, Miss Barnett. What is it?
The arrow on the top, Miss Cintron. We have to put the arrow on the top.
Why?
So I know what you're talking about, and I don't think it's a line segment.
There we go. Is there another ray, Miss Barnett?
Yes, there is.
Can you do the other ray?
Yes, I can. It is H. And I'm going towards C, so it's going to be H, C. And I'm going to put the arrow on top so I don't think it's a line segment.
All right, there it goes. So this is how we name an angle. This is where the vertex is. Here's the rays. Over here, an angle is measured in degrees. This is the symbol for degrees. Maybe we know that. Maybe we forgot.
I covered it up by accident.
Uh-oh.
I should have highlighted it right there.
And degrees are based on how much of a circle that angle makes. A cross circle is how many degrees?
I bet everyone's saying it at the same time. Are we ready? Can I hear it? It's 360 degrees.
360. Like, I would say when they do like the snowboarding, when you watch that, if you do a 360, they have turned in a full circle. Generally, our students know about that. Or skateboarding.
Skateboarding, yeah.
Snowboarding, I guess, is more my thing. Snow. All right, now we're going to classify angles. I think they've heard of this before.
I think so too. I think this is from middle school, 7th grade, maybe. Yeah, 7th grade, middle school.
So, if we have the acute angle, how many degrees would that be?
That is less than 90 degrees because it's such a cute little angle.
90 degrees. Now, obtuse angle is
greater than 90 degrees because it's obtuse. It's big.
And a right angle is
exactly 90 degrees.
And a straight angle is
180 degrees. Exactly.
Okay. So now we get to name some of these. Let's decide, though, which one of these is 90, because we probably know that.
This one's 90.
And that one would be 90. What's generally in the corner of these 90-degree angles?
You know what? I'm glad you bring this up, Miss Cintron. There is a little box that is usually there that tells us it's 90 degrees, so we don't have to write all that stuff down.
So if this is our 90-degree angle, which one is smaller, more squished in than that?
The one to the left, Miss Cintron.
Oh, this one?
Yes.
Is this the cute one?
That's the cute one. It's a cute little angle.
Now, do we know exactly how many degrees this is? Ms. Maria?
No, I just know it's less than 90.
That's
I don't
all
know.
we need to know?
Yep.
Okay, moving on. What's this one then?
That's a straight line. So that's a straight angle.
Must be a straight angle. Must be 180 degrees.
Okay.
What would the last one be then?
Well, because we have eliminated everything, it's going to be obtuse, but also I can tell it's bigger than the 90-degree angle. So this one, oh my goodness gracious. I thought I broke it. Oh, your board's being funky. Obtuse.
Yeah, that's the board.
That's okay.
For the folks at home, I might be getting a new board. If you'd like to donate, we'll have a number on the screen at the end.
A GoFundMe for a new board.
All right, we're changing pages here.
Okay.
Now we have adjacent angles. We're still going, right?
Yep, we're still going.
Adjacent angles. Okay. So
Okay, we're good. Yep, we're good.
Adjacent angles. If P is in the interior of angle RST, so interior, inside, then blank and blank are adjacent angles. Adjacent sounds like a very big and fancy word.
But what does it really mean, Miss Cintron?
I forget. I think it means next to each other. Like, oh wait, turn around, Miss Barnett. We are adjacent. Now we are not.
Oh, you hurt my feelings.
Well, we can't always be adjacent.
Obviously.
Yeah, this year included.
Yeah.
All right, so we are next to each other. This one is stuck to that one, like we were just stuck to each other. They're stuck by Ray SP. She's writing out the adjacent angles. Angle RSP. That's this one. RSP.
I'm going to do it this way so that the ray that they share, you can see it in both.
And then she did TSP. The one that I marked 2 times is the one that they share, right?
So that would be SP.
Again, she went from the vertex to the direction of the arrow. She did not forget her arrow on top.
Never.
No.
I would never do that.
Nor would she. The measure of angle RST is the...
I think if I have a little angle plus a little angle, it will give me the big angle. That sounds kind of familiar to me.
I think you're right.
I think it's this sum.
Another fancy word, 3-letter fancy word. Sum, the addition of the measure of the adjacent angle. So if we add these two together, we get the whole big piece.
You're wearing your mask.
Oh my gosh. I need to wear my mask, guys.
Yeah, we hang out way
Forgot.
too much to wear our masks.
Anyway, angle addition postulate tells us exactly what Ms. Barnett was trying to say. If we add the 2 smaller angles, we're going to get the big angle measure. So the smaller angles here are the 120 and the 40. We have to name those. And we know from past experience that naming angles is difficult. The vertex is always in the middle. If the vertex is not in the middle, you're wrong. So fix it. C-A-R, C-A-R.
An A-R-T.
A-R-T?
Oh, I didn't put the vertex in the middle. R-A-T.
Look at, we spelled some words.
Oh, that's so cool.
Yeah. Car and rat.
Uh-huh.
Huh.
Who knew? Okay.
Okay. So they're adjacent. That means that the 2 measures are going to be, if we add them, they're going to equal to the big angle. So the measurement of C-A-R tells us it's 120. Right? C-A-R is 120. What is R-A-T then?
I think it's 40. That's what it says in the drawing.
Because it says it, right?
Right.
That equals the whole thing, C-A-T, cat. So it would appear that a car plus a rat equals a cat.
That's a very interesting story, I think, behind that.
I think that says something. 120 plus 40 is?
160.
All right, 160. Miss Rhonda, there's some new notation up here. This little M. I don't know if we talked about that before.
We did. So M stands for measure. And that is the degree measure, or the number. So that's looking for the number degrees. Is that a good way to explain it?
Yeah, I think
Okay.
so. I just didn't think we've seen that before, but maybe
Yeah, we haven't actually. This is the first time. You're right. We kind of jumped through that.
We did. Jump down that rabbit hole. All right, now, oh my goodness, we don't have numbers, but we have letters involved, and this is where things get a little
I'm not going to do this. It's too complicated. I don't want to do it in this intro. I'm not going to do it.
You don't have a choice. So we're doing it. So we first have to figure out what are the two small pieces. So here's a small piece, right? That would be angle RSP. And here's another small piece, I guess a different color. Go Christmas. Angle TSP. I should have my measurement symbols in there probably.
That's okay.
Measure equals the whole thing, the big angle, RST. So it's just like we did with the segments, with the line segments. The small piece plus the small piece equals the big piece. So the small angle plus the small angle equals the big angle. Well, now we've got to substitute in what we know. Do we know anything about RSP whatsoever?
Yes, we do. We know that RSP is 2x plus 10.
All right. Is she going to keep this plus sign or throw it out?
I'm going to keep it.
I think we should keep it. Do we know anything about TSP?
Yeah, because TSP is the same as PST.
So I wrote it backwards, guys.
That's okay. It's the same thing.
And do we know anything about RST?
Yeah, they tell us it's 85.
So she's just substituting in.
Oh.
This looks like a job for Desmos. All right, should we do that together or should we,
We're going to pause because we're running out of recording time. So we figured out that x is 16 because of our handy-dandy Desmos.
but is that what they asked for?
It says, find the measure of PST. We found x, so we didn't answer the question yet, Ms. Cintron.
Problem.
So I'm going to go to PST. So angle PST is equal to 3x minus 5. So I'm going to substitute that 16 in. I can do this in Desmos so I don't make a mistake, and that's equal to what, Ms. Cintron? What did Desmos tell us?
43.
43. That is the answer.
Yay!
Okay.
All right, last but not least, it's off.
Okay.
Okay, so now we have the angle bisector, and we remember from the segment bisector that it cuts the angle, or cuts the segment in half into two equal parts. So it's a ray, segment, or line that intersects the vertex of the angle, and what goes there? Cuts it in two equal parts.
And yeah.
Yeah, that's exactly what it is. All right, cuts the angle in two congruent parts.
What's congruent mean, Miss Cintron? I know we learned it already, but let's.
Congruent roughly means equal. For our purposes, we'll just say equal.
Okay.
The adjacent angles will have if they're equal, what kind of measures do they have?
The same.
Same measures. So now we're going to actually figure this out. Given the line segment RS, oh, look at this. That is not. All right, line segment OC bisects AOB. That means it cuts it in half. So we know AOC is x plus 40.
Miss Cintron, are you labeling your picture?
I always do.
See, because you're smart like that.
Well, I'm trying to get an A. That's how I am. I don't like anything less than A. So this is x plus 4, this is 3x minus 40, 3x minus 20. We know that they're equal. So how do I set up the equation?
So I'm going to say x plus 40 equals 3x minus 20. And then I put it into
Desmos.
Woo!
And
And I
x
get-
equals 30.
Okay.
Are
That's
we
not what I
done?
want. Nope, because they want to find the measurement of angle AOC, not x. So I'm going to plug that into angle AOC.